Alrighty. I'm back. I'm not sure what happened. It wasn't power failure of any sort, but for some reason, OBS got disconnected. Maybe it was a network failure. Yeah, let's continue. Let's get back to it.
Ovin login. Let's step through this code line by line so that we may understand what is happening here. This function takes one argument, in, which for the sake of this example will be 4. We then declare another variable, y, which we will set equal to in. We will get to what this variable y is for later. And at this point, we have a while loop that iterates through in until in is equal to 1. For every iteration through in, this code within the while loop is run. Let's visualize this. For the first iteration of the while loop, in starts off as 4, but we divide it by 2, so in is now equal to 2. Then we get to this line of code, which is the start of a for loop. This is where this variable y comes in.
Oh, it's sort of like when a linear when the linear complexity gets mixed with the logarithmic complexity.
The reason we declared this variable before the start of the loop is because in is getting divided by 2 for each iteration. This in turn is reducing the size of the variable in, but for this inner for loop we needed to iterate through the original size of our original in, so we stored the original in a separate variable. Okay, back to this inner for loop. For each iteration of this for loop up until the size of in, we will log or print the value for I. Once this is finished, we move on to the next iteration of the while loop and repeat the process. Going into this iteration, in is now 2. We start by dividing in by 2, so in is now 1. And once again we iterate through our inner for loop up until the size of y. Now at this point, you will notice that our in is now 1. If we check the condition of our while loop, we see that we only want to iterate while in is greater than 1. So the while loop will now terminate and the function is finished. Now, after all is said and done, and with everything written out, we can see that there's a top level loop here. And there's an inner loop for each iteration of the top level loop. So this is where the magic happens, so pay close attention. For every iteration through the top level loop which iterates until in is 1, in is divided by 2. This means that this top level loop never actually iterates through the full size of our input, in. The value for in is being split in half for each iteration, which is why we would say that this top level loop has a complexity of O log n. If you are confused about why this top level loop is O log n, let's take some time to prove it by writing it out. So this is O log n. Let's plug in some numbers. Now if you've watched my video on O log n, you know that in computer science the base of a logarithm is always 2 unless stated otherwise. So this can be rewritten as log base 2 of 4, 4 because we are replacing in with our actual input for in, which is 4. And log base 2 of 4 is 2 because you need to raise 2 to the power of 2 to get 4. And as you can see, this makes sense because for this top level loop we only iterate 2 times. So for this top level loop we have log base 2 of 4 equals 2. Now we need to take a look at what is happening in each of the 2 iterations of the top level loop. For each iteration, we loop through the full size of y, which is the original size of in. So that means that each of these inner loops has a complexity of O of in, which just means that processing time increases linearly with the size of in. Now this is where we bring everything together. O of in log in really just means O of in times log in.
Yep.
And if we plug in some numbers here, we get this. Because remember, log base 2 of 4 equals 2. And if you look at our visualization, it makes perfect sense because for each iteration of the top loop, we iterate through the entirety of y, which is our original value for in. And that, ladies and gentlemen, is how you visualize O of in log in. So we can start by creating.
Let's actually go ahead and create the complexities.js file first, and then we'll look into merge sort. So actually, what do we call this? I mean, we say n log n, but it should have a, what is n log n complexity called? Log linear. Okay, let's call it that then. And I guess it makes sense to call it that because it's a combination of logarithmic and linear complexity. We'll copy the logarithmic complexity over. Let's rename this to log linear. So let's see here. Let's also go ahead to our linear complexity and we'll take in this for loop, except let's put this inside and then um let's go back for a second here. Oh yeah, we, to get the initial value, we do let y equals n. Okay, And let's print n, and also let's print y. And just to make it even more obvious, let's mark this as logarithmic. Let's mark this as, oops, I'm forgot I'm in Node. So we need to use this double slashes to mark a comment. Not a comment, haha, comment, but yeah. And this would be linear. This would be logarithmic. And this entire thing would be log linear. And let's cd back into complexities, and then let's run node log linear complexity. Yeah. It's actually printed out. Let's just check this out real quick. So this entire thing would run n log n, right? So 64 times 2 raised to 6. 64 times 6 is what? 384 times? Does it run 384 times? I guess let's test it out. Let it count equals, let's set it to 0, right? And we can update the count. Let's also run it, print data count. 384, there we go. Ran for iterations. Great, now let's go back.
Ladies and gentlemen, is how you visualize all of in log in. So we can start by creating a file. Let's just call it merge sort. We'll then create a function, which we'll also call merge sort. The argument to this function is going to be the array that we're looking to sort. For the first portion of this function, we'll need to make sure that the array that we're passing in has a length greater than 1. We will need to do this because if the array is only of length 1 and there's only one element in the array, then it is already sorted. This will also be our base case, as this merge sort function is going to be a recursive function. Next, we're going to need to split our array in half. To do this, we'll first need to find the middle index of our array. So what this snap.floor here does is it makes sure that we only take into consideration the base number from the result of the division. So for example, if we divide a number that results in, I don't know, let's say 5.5, we wouldn't take into consideration the number after the decimal point. So we would only return to the variable the number 5. And this is because when taking indexes into consideration,
I really like this form of editing where he's explaining via Blackboard too.
there is no index 5.5 or 2.2 or 1.1. There would only be an index 1, 5, or 2. So this is why we're using math.floor here. And once we have the middle index of our inputted array, we can then split the array in half and create a separate array for the left side and a separate array for the right side. So we can do that by just creating a new array, left array, and then we can set left array equal to the input array dot slice, and then the indexes are going to be the arguments that we pass. So basically slices from and to. So we want to slice from the first index of our input array, and we want to slice up until the middle index that we just got. And that's because we want the left side of the array. So let's say, for example, the array looked like this. And we went ahead and got our middle index, which would be something like this 3 here. And then we want to create an array starting from this 0th index up until our middle index, which would be the left half of the array. And then we would go ahead and do the same thing for the right half of the array. So we're going to actually go ahead and do the same thing for the right half of the array. We'll just call it right array. And we'll do array.slice again. But this time, we're just going to do from the middle index all the way until the last index of the array. And the way we get the last index of the array is just by using array.length. And this here can actually
You need to do -1, right?
be a bit confusing because we know that array.length gives us the length of the array, which is the number of elements in the array. And we also know that array indexes are 0 based. So basically, if the length of an array is 5, there will only be index 0, 1, 2, 3, and 4. There won't be an index 5. So here you might be wondering how this is actually working. And it's because, oh, actually there's an error in this method. It's not slice, it's just slice. But it's because this slice method slices up to in, but not including in. So
Oh, yeah, that's right.
So basically, this in value, it's not included in the actual array slice. Only the value before will be included. So for example, if we have an array that looks like this, the int that we would use for this array would be 3, even though that there's only index 0, 1, and 2. It will.
Yeah, it's sort of like Python slicing, right? Yeah, that That makes sense.
until end, not including end. So this is why we don't need to subtract a 1 from this, because if we were to subtract a 1 from array.length and use that as the last index or the end index that is passed to the slice method, then we actually wouldn't get the full array. We would only get up until this one, but not including this one. So the array would only look like this in the slice. I hope that makes sense. It's a bit confusing. And also keep in mind that with this example I just gave above, I'm actually not taking the middle index into consideration. So for this array in particular, it would look something like array.slice, slice, and then it'd be 0 index up until array.length minus 1. Anyways, last but not least, for our actual merge sort function, what we're going to need to do is implement the recursive portion of the function, which is we're going to return, and bear with me, we're going to return a helper function that we haven't created yet, and we're going to call it merge. And within this merge helper function, we're going to accept two parameters, which is going to be the left array and the right array. And what we're going to pass to merge is going to be the recursive call to merge sort, and then our left array. And we're also going to pass in the recursive call to merge sort and our right array. This is going to seem a bit confusing right now, but just bear with me. I will explain how this is working, and I will try to make things clear for you. But for now, we don't actually have this merge function, so we need to go ahead and create it. So let's go down here and create this new helper function called merge, which will take in the left array and the right array. Oh, sorry, and it's not merger, it's merge. Now this function is going to be the function that actually merges the two arrays. So the way that merge sort works is we use a divide and conquer approach, in which the input array is basically halved until we have n arrays of length 1. And at that point, arrays of length 1, as mentioned above when we created this base case here, an array of length 1 is already sorted. So to visualize this, if we have an array that is 1, there's only one element in this array. So
And we take the 0th index, compare it, and then merge accordingly,
this
right?
one is going to be the first and last element in the array. So there's no need to sort it because there's nothing to compare it to. With what we do in this actual merge function is we're going to bring these sorted arrays together and compare them and then sort those individual one element arrays. So one thing to keep in mind throughout the process of writing this merge function is that this merge function is always going to take in two already ordered arrays, starting with the ordered arrays of length 1. So to start, we're going to create a variable which is going to just be the result array, and it's going to start off as an empty array. So result array equals just an empty array. And we're also for right, whatever element is less than the other will get added to the result array. We'll then increment the index of whichever element got added to the result array. Compare. And actually, there's a mistake here. It's just length. So within this while loop, we're going to compare each element of both arrays, and whichever element is less than the other will get added to the result array. We'll then increment the index of whichever element got added to the result array because that element no longer needs to be compared. If you're a bit confused by this, just bear with me. I'll actually create an illustration for you to understand it better. But for now, let's just write out the code. Now let's imagine that the arrays that we want merged look like this for the left array and this for the right array. Now keep in mind that the merge function merges ordered arrays, so it will not work on unordered arrays. In this example, we are merging two ordered arrays of length 3 to show the entirety of the function's functionality, but this will also work for naturally sorted arrays of length 1. So for this while loop to continue, both left index and right index need to be less than the length of their corresponding arrays. As you can see, these indexes are incremented every time that index's element is pushed to the result array. So if we draw this out, it looks something like this. Here are the two arrays and their indexes. In this next line, we check to see if the element at the left array index, which is currently 0, is less than the element at the right array index, which is also 0. So is 3 less than 1? No, so that means we do what's in our else condition, which is push the right array element at its current index to the result array and increment the right array index. And now our right array index is 1, so we can move this. And then once again, we do our comparison at the top of the for loop. Is 3 less than 6? Yes, so we push 3 onto our result array and increment our left array index. And we can move this over as well. And back to the top of our for loop again. Is 12 less than 6? No, so we're going to use the code in our else condition, which is push the right array element 6 to the result array and increment the right index. And again, we will move this. And now, is 12 less than 15? Yes, so we push the 12 from the left array to the result array and then increment the left index as well as move this arrow to the new left index. Now is 16
Alright.
less than 15? No, so we move on to our else condition and push the 15 from the right array to our result array and increment the right index by 1. Now at this point, this while loop will terminate because if you remember, this while loop will only continue if the left index is less than the left array's length and the right index is less than the right array's length. At this point, our right index is equal to the right array's length. As you've probably already noticed, there's still a 16 left in the left array that has not yet been pushed to the result array, but the while loop is already complete. So what do? After the while loop, we're going to add another line of code that looks like this. So this return is going to return a single array that is a combination or concatenation of 3 arrays, the result array, a slice of the left array, and a slice of the right array. So this slice function, if we only pass one index to it, it will be used as the start of the slice and will slice up until the end of the array. Let's break this down. So if you remember from the last slide, our result array currently looks like this. And we're going to add to it a slice from the left array starting from the left index that we incremented, which is 2, which results in an array containing only this part. And we're going to add to that a slice of the right array starting from the right index that we incremented, which is 3, which results in an empty array because index.
Yeah, it's completed.
And with all of those combined, the result being returned is an ordered array that looks like this.
Why are we using concat? Because I believe JS doesn't support the plus, like the actual plus operator for arrays. I mean, it does, but it provides a string, I believe, or something weird like that.
And now let's go ahead and add in the return that we just discussed in the illustration. And this completes our merge function. And now that the merge function is complete, our merge sort function is also complete. And this completes our merge function. And now that the merge function is complete, our merge sort function is also complete. And now we can go ahead and test this out. To test this, we will need to create
Let's actually create this. So we have left array, right array, and then this for merge, right? What about for merge sort? We just have the array. Okay, let's sort it out real quick. Or let's just yeah, I think we'll sort it out in the next session. It's almost time here. So yeah, we covered quite a lot, and I believe whenever we do the next stream for this series, we should be able to end this, right, based on the rate at which we're going. So yeah, this would be a yeah, it would be a longer course because there is no specific rule like the course ends when the video ends or nothing like that, right? So yeah, let's see. As always, yeah, I'm really excited for what is to come, and yeah, okay, I guess I'll be ending the stream now. Take care, and I'll see you in the next one.